Hello, friends. We are back with episode 224 of the Our Weekly Highlights podcast. And this is the usually weekly show where we talk about the great highlights and other resources shared at ourweekly.org. And just a quick admin note, as much as I was saying we were going to try and be consistent with our week-to-week release, unfortunately, we did not have an issue last week. So we were off, but we got a new issue this week, so we are back. My name is Eric Nance, and I'm delighted that you joined us from wherever you are around the world. And joining me virtually, as always, is Mike Thomas. Mike, how are you doing today?
Doing pretty well, Eric. Fighting the spring allergies, but got some Flonase going, and got to power through this.
Yeah, I feel like I got that midweek here. It's different than when I was sick like a month ago, but it's enough to be like, yep, the season's changed, the molds are out there, and next time I have to mow the lawn, I'm probably going to sneeze 50 times, but it is what it is. First world problems, I guess. Could be a lot worse, but we're going to talk about positive things. Yeah, about positive things today. We got a great selection of highlights, and our curator for this week's issue is Jonathan Kitt. And as always, he had tremendous help from our weekly team members and contributors like all of you around the world with your pull requests and other suggestions. And we're going to lead off with a great utility in the land of the tidyverse and data processing, and getting a glimpse into kind of what's happening maybe behind the scenes, or at least through a typical, dplyr-like pipeline. So I think most of you listening to this are familiar with the tidyverse and dplyr in particular, where you get your full gamut of being able to create new variables, do filtering, do other transformations. It's become a big staple in the world of data science and data munging in particular. Well, when you run dplyr off the shelf and you're doing a batch of mutate, filter steps, you typically won't see any output unless you ask for that resulting data frame that you get back out of that pipeline. That's typically by design, right? Most pipelines will, only let you opt into more verbosity if you want to. Well, in the world of other languages, especially one that is still fairly dominant in my industry, such as SAS, you do get, in its proc data step, actually a pretty copious amount of messages in SAS's log file when the data processing is being conducted, such as a number of observations and maybe some records that were deleted or added and whatnot. But up until now, there wasn't really an equivalent version of that in the world of dplyr or tidyverse pipelines. Well, in our first highlight today, we are going to talk about a new R package called logrittr. I'm going to take a venture, that's a way to pronounce it, given its similarity to magrittr, which is tagged as a verbose pipe operator for logging dplyr pipelines. And this package and accompanying blog post is offered by, we're going to try my best at this pronunciation, iamYannC. I believe that is French. Correct me if I'm wrong out there. But he has created, like I said, this aforementioned package called logrittr. And on the tin, what it gives you is a different operator that you can use to replace your call to either the magrittr pipe or even the base R pipe. And the operator for this is surrounded by a % with a greater than sign and an equal sign immediately afterwards. So much like the magrittr pipeline, which I believe also had its origins from France, but you just add an equal sign after that greater than sign in between the % signs. So in the example in the blog post, the author does a simple filtering and mutating step with the iris data set. And what you see is the output is showing kind of these interesting messages in the terminal that at each step of the pipeline, whether it's just converting it to a tibble, doing the filtering, doing the mutating, it's going to indicate the number of rows, the number of columns, the time it took to complete it. But as far as kind of like a diff is concerned, it will show next to the appropriate rows or column numbers how many were either added or subtracted at that particular step. So for instance, when it does the filter for the sepal length being less than 5, it goes from 150 observations in the iris data set down to 22. And then it has, next to that 22, the delta of that difference, minus 128. So this could be very helpful if you want a quick read in an audit, so to speak, of what's happening in terms of the number of observations and the number of variables that are being added or subtracted. So this one is, again, very utilitarian. The rest of the post does mention that the package does play nicely with another package that we may or may not have talked about maybe last year called Lumberjack, which kind of has its own unique take on messaging and logging with respect to tracking changes in your data with typical dplyr-like pipelines. So that might be interesting if you want to do a nice combo of those together. But this is a very interesting take on this. The post concludes with some limitations in that this is really only going to be supported for data frames themselves in your R session, not so much with databases themselves that you might interface with the dbplyr package as your front end to those kind of queries and whatnot. And it sounds like join cardinalities are a little bit difficult to handle, but it looks like he is working on that. But yeah, he invites others to give it a test, and there will be a link to the package documentation in the show notes, but it might be a useful tool if you want just a little bit of a glimpse into what your dplyr pipeline's doing to your precious data.
This is a really cool new package out there, and I think as Guillaume says himself in this blog post, it's really kind of pushing the boundaries, or he was really exploring what you can do with CLI, the CLI package. And if you see kind of this beautiful console printing with this header at the top and then sort of information graphics and things laid out in very structured rows neatly in the console, it's fantastic. I mean, the information is just presented there so nicely. And I think we've seen probably, in the last couple of years, a lot of movement to kind of beautiful CLIs, not just the CLI-R package, if you will. And I think this is a great example of that as well. One other adjacent package that Guillaume mentions is the TidyLog package, which he said gave him some motivation to develop the logrittr package. But TidyLog, in a different way, kind of works by masking dplyr functions. Instead of really working alongside dplyr instead. So I, like you, Eric, are probably a little too familiar with SAS proc log outputs and having to take a look at not only like a SAS script, but also sort of the log script that goes alongside that. And I'll be honest, it is nice to be able to kind of see those logs and help keep track of what's happening to the data behind the scenes in a way that is often abstracted from us if you are working in R and not baking in a lot of CLI or print statements or logging or updates, things like that. So this is a really, I think, convenient way with this logrittr package to be able to kind of fill that gap.
Yeah, and it's amazing how the SAS logging paradigm has had such influence, especially in life sciences, that there are packages in R to try and replicate a lot of that functionality. This is certainly scratching a bit of that itch. Even in the Pharmaverse, there are certain packages like logrx and the like that are trying to make it so that it's easy as an R user to have that log ready to go in case you need to audit it for more regulatory purposes. But yes, it's good to have, because I'm going to call it like an in-between here because it's so easy to opt into this. And it's just one pipe operator different. Everything else in your dplyr code can remain the same. There's no like hidden options you have to specify at the top of your script. This is a really elegant solution, and I'm eager to see, maybe what future development is in this great package. And our next highlight today is very much feeling like we're going back to school a bit on a concept that is easy, and I do mean really easy, to take for granted, but has so much going on under the hood that I did not realize, or maybe I just didn't think to look until this great highlight that came to our eyes, so to speak, in this week's issue. And the author and the title of this highlight is Generating Universes Within Universes with a Single Seed. There's a lot to unpack even in that message alone, or that tagline, and we'll unpack that here as best we can. And the author of this post is the esteemed Andrew Heiss, very frequent contributor to our weekly highlights. Always an entertaining read whenever he posts out there. And yes, he is such a modern stack with what he's building in his educational materials and his online presence. And there's some cool modern stuff in this post here. But let's kind of dive into this a bit. Mike and I will tag team on different parts of this post here. But in essence, seeds are a critical part, and this is speaking from my experience as well as a statistician, to ensure reproducibility in whatever random-ish kind of process your analyses are employing. And this is especially true as we look at algorithms from, say, Bayesian methodologies and even just simulation of data itself. We want to make sure that we can have that one ID that we can assign, so that if we run this over and over again in a different R session, we will get that similar result. Now, and then Andrew, of course, has been using seeds, I think, for as long as I have in R. And in fact, the post starts with an area that you might not expect seeds to play in, and that's with ggplot2. When you want to tackle over plotting, in the case with the Palmer Penguin data set, where if you just do the geome point by default, when you look at the facets of species on the X and island on the Y, you just get basically 6 or like 5 dots on the plot, but those dots have a lot going on because they're the same. But if you want to distinguish them, you want to introduce a jitter. So then you get that kind of scattered representation of all the data points. Instead of seeing just 5 data points, you now get the full set of data points. But if you run that jitter code again, the pattern will look different, because that jitter is actually a randomish process for how it's jittering all the points. So if you want that pattern to be consistent, you got to set yourself a seed there. And that is, again, how to do this in R. It's a one-liner, folks. It is just set.seed, and then you give it a number. We'll get to how big that number is in a little bit. But even before that point, the post has an entertaining diversion that seeds are also used in many different places outside of statistical programming, such as Minecraft, when it generates that world that you are spawned into. Unless you tell it to with a seed, it will always be random each time. But you could set a seed, and it will use that in its procedural generation of the different worlds out there. And there's been a whole rabbit hole that many in the Minecraft community have gone down to try and kind of see interesting things that happen with specific seeds. So yes, there is a subreddit just for that alone. That would be an interesting time sink on the weekend. But back to seeds themselves. So Andrew's had kind of a notion of how he thought this would work. But let's first kind of take a step back here. And what is a seed exactly in the big picture here? Well, the definition that he highlights here is that it's an arbitrary integer that R's internal random number generator, or RNG for short, whatever that algorithm needs to initialize that process. That will be a key we also get back to later on. And you could use, as I said, many, many different numbers for this. Even to my 80s or 90s heart, puts in my favorite seed of 8675309. Yes,
Love it.
I will not quit my day job. But it's my favorite one. And I won't lie, I have used this in for actual projects. Goodness gracious. Okay, anyway. So
Jenny.
Yep, Jenny, baby. So in the rest of the post in the next section, he talks about what kind of he's been telling his students based on his mental model of how seeds work. And one interesting exercise is that when you use the runIf function, or runIf in R, this is the function that will let you generate random numbers from the random uniform distribution, another staple in statistical theory. And of course, if you run this with, say, 5 to get 5 numbers repeatedly, they'll be different every time. But then when you set the seed and you run that, the first time you will get a set of 5 numbers. And then he had the other students in his class set that same seed, run that same line, and they all get the same number that first time they run it. It's interesting that if you run that statement again, the runUif of 5, you get a different set of 5 numbers. And what's interesting about this is that these random number generators are in essence giving you a sequence of these numbers, and you just kind of, in essence, push them or pop them off a stack every time you call this different invocation with the same length. And so what is actually driving that process? It's not hocus pocus. This is based on mathematical theory. Just where does this grand list of numbers come from? So there is a relatively classic algorithm called linear congruential generator, or LCG for short, that actually has a set of key parameters in this sequence. And he has a nice notation of the equation in the blog post here. But some of the key inputs include things like the multiplier, the increment, and the modulus operator that in essence help you determine what the next number will be based on what was the previous number. And hence, what's interesting is that you need something to start with, because it's based on what was done previously. And that what you start with is, you guessed it right, is that seed that you define up front. That kicks off the entire sequence. And what's really cool about this post is that Andrew has a way for you to interactively play with these different inputs to this LCG algorithm in both a downloadable Excel spreadsheet, XOSX file, as well as an embedded, looks like a JavaScript widget that you can literally put in the numbers, and it will update it on the fly with the sliders you can toggle. I'm doing it right now. And you kind of see what the next numbers will be in the different sequence depending on the numbers you decide to generate. You can go anywhere from 12 up to much higher too. This will be a fun way to play with this a bit. And here's the nugget that he's found in researching this algorithm, is that eventually you're going to reach a point where there is a cycle of numbers and they are repeated. That kind of took me a step back a bit, that these are not all unique numbers in this sequence. There is a time, and this is actually a limitation of the LCG algorithm, where you will have to, account for these different periods or cycles based on those inputs that you put into the equation. So, hearing this limitation, you may be wondering, are we in trouble here when we do random number generation in R? No, threat not, because R itself does not use the LCG algorithm as its default. It actually uses a more complex technique, and the default for R at the time of this recording is called the Mersenne twistor algorithm. This is a very interesting one. There are links in the blog post that talk about this in more detail. But in essence, you can be assured that it will take a long time for you to encounter this different cycle to repeat itself. And you might say, how long will it take? Well, it takes about 2 to the power of 19,937 minus 1, which you don't need me to tell you That's a really big number. So until you hit that number, you're not going to see this repeated sequence of numbers in your random number generator. He also shouts out a great post from Danielle Navarro when she looked at, in 2023, a blog post that she authored called Seed Catcher to try and dive into more of this Mersenne twister algorithm. It's a cool read as well. Now, in and of itself, this is a great start, right? But there are some interesting things that you can encounter. And in essence, there were some hot takes from very esteemed members of the community on this. And in fact, the esteemed Claus Wilk has a great take of, if your random seed is 42, I will come to your office and set your computer on fire. Shades of Jenny Bryan there with the workspace line in the top of our scripts. And that is just kind of a dovetail into what are some of the pitfalls that might happen based on random number generator that you might want to watch out for. So Mike, why don't you take us through kind of what other takes on this hot topic that we're seeing here?
Yeah, I mean, I think the core idea that Andrew's trying to present here is that, random isn't really random because your seed is going to kind of create this fixed, predetermined downstream sequence of numbers, which is great, right, for reproducibility, but also can hurt for other applications. You're kind of walking through a pre-written list and not generating complete randomness on the fly. So, kind of using a seed is like choosing a universe where every random event is already sort of decided. And when obviously you use those common seeds, 42, 1, 2, 3, 4, it means that you and everyone else are kind of exploring just that same select universe and not trying other universes, if you will. You're just exploring that same sequence of numbers. So it creates sort of artificially limited variation in our analyses. There's infinite universes, but everyone keeps picking the same one if you're all choosing the same seeds. And another thing to think about here is the possibility of seed hacking. So you can search for a seed that gives the result that you want. And I would be lying if I said that in the past I haven't changed my seed or a few different times to try to make my plot look a little bit nicer, to explain the point that I'm trying to get across. I will say that I have never, because I don't think I could sleep over this, just changed my seed to like change a coefficient from negative to positive or something like that. But you could think that that's certainly possible, and there is an area in the blog post where I think that there were Naimi Yu and Bodnard. I'm not sure what their first name is, but the link in the citation is here in the blog post. They used sort of several different machine learning techniques, random forests, neural nets, which all incorporate some element of randomness. They analyzed the same data and estimated sort of the same average treatment effect, and the estimated effect varied substantially based upon the seed that they chose. So that makes it tricky, and obviously leads to a lot of potential for seed hacking, or not only seed hacking, but just only seeing things in your individual universe and not really baking in enough variation to sort of take a look at all of the different possibilities. And I think when you get into like InfoSec and things like that beyond data science, that's where you start to have some real world consequences of this, because people can exploit this in ways that are fraudulent. And Andrew makes sort of leads into sort of a next section about how you can potentially get around this, because the conclusion here is that computers themselves just can't generate true randomness on their own. So if you kind of know the algorithm that's being used and you know that seed, that starting point, you can predict all future values. So pure algorithmic randomness is kind of deterministic under the hood. And Andrew's argument for creating real randomness is that you need some sort of external, like physical process or physical entropy in the world. And he has some great examples of this. One of my favorite here is Cloudflare. I don't know if you saw this,
yes,
Eric, but they're one of the largest like content delivery networks, CDNs on the internet, and they handle a ton of like encryption related tasks like SSL encryption, think HTTPS type of stuff. And they have this wall in their office of, I don't know, 100 lava lamps, something like that, in their San Francisco office. And they have a camera that just watches this wall of lava lamps, takes a picture of the state of the fluid moving around in these lava lamps, assigns a numeric value to the pixels in that picture, and then generates a seed or a truly random sort of process downstream based upon that physical picture of the lava lamps, which is a wild thing. There's a couple other examples here where there's a service called PGP, I think it stands for Pretty Good Privacy.
Right.
It's like a terminal interface where it lets you move your mouse around and kind of type random stuff into your keyboard, and based upon your mouse movements and whatever you typed, it will create a truly kind of random pseudo-random seed for you. And there's another example using atmospheric noise. Is a company called random.org that has 3 radios that capture atmospheric noise and then uses the entropy of that noise to generate truly random numbers. And that's something that Andrew shows he actually uses quite a bit. He'll go to random.org to first type some random number into random.org, and then whatever that spits out he'll use for his seed. So I thought that was pretty interesting there as well. And I think sort of the big philosophical takeaway here is every coin flip, every shuffle or simulation outcome is already going to be predetermined the moment that you set your seed. So I think it's important to make sure that you're leveraging a lot of variation in the seeds that you choose from project to project.
Yeah, it's really interesting to see not just the parts that are happening in our actual programming work, but then how these other industries are tapping into these other processes to give it that additional random-ish start that is easy to miss. So I won't have the budget to buy all these lava lamps and take pictures like Cloudflare does. That was a really interesting find that Andrew put in here. I am intrigued by that, like random.org kind of integration. I think that could be really cool in my next project to at least have a script like he has here to get that seed started. And of course, I document that seed for prosperity and my simulations or whatnot. But that probably will be a nicer thing too, as the post mentions. Maybe step outside my comfortable universes of 8675309 and do something a little more robust than that. So there's a lot to learn here. I think it's fascinating for a concept that is, from implementation side, as easy as it gets. It's a one-liner, but what goes into that line? Yeah, a lot of things to consider, not too dissimilar to other parts of the data science process that you mentioned, when people kind of hack seeds, so to speak, that this post highlights. I mean, it is maybe not quite as egregious as p-value hacking that often happens when you run inferences over and over again until you get to that right result that you want for that less than 0.05 level. But it can lead to consequences not too dissimilar to that. So it is worth thinking about in the long term. But yeah, there are definitely mechanisms you can take as a data scientist right now to give that seed a more gentle or more randomish start. So really cool stuff here.
The deepest dive on seeds I've ever seen.
Yeah. And if you didn't feel the need for seeding, well, you sure do now after that. But and then rounding out our highlights today, they're actually going to be a bit abbreviated with this last one because yours truly did some sleuthing and tried to find the recording of the talk that this mentions, and I could not find it. But we'll give a quick shout out here to Nicole Arini, another frequent contributor to the highlights, where she, amongst others in the Our Ladies remote group, were part of sounds like a really interesting panel discussion that was tagged Working Smarter for R, Tips, Tricks, and Real-World Lessons. So, without access to the talk, I can't give you like my Reader's Digest version, so to speak, on the points they highlighted. But what I can say is that the link we have in the show notes has a copious amount of additional links that, admittedly, I don't have the full context around, but there are some interesting things you might look at as you're waiting for the talk recording to get out there, covering the full gamut of our Markdown, Quarto, some of Nicola's recent work on visualization, and yes, even the targets package. Always a soft spot for that, amongst others. So definitely additional links within our weekly. That's kind of what we're specialized in, that might give you a starting point to working smarter with R. And with that, we're going to put a bow on this episode of our weekly highlights. We got to get out of here kind of quick, so we don't have time for our additional finds. But as always, we invite you to check out the issue and, read at your leisure for all the great content that's shared on this and in the back catalog as well. And of course, this project is built on the community, which will be a very key point that I highlight in my upcoming lightning talk at PositConf about R Weekly. And one of the best ways to contribute is to share that great new resource, that blog post about a package, or another great find. We're just a pull request away, folks. If you're comfortable with Markdown and GitHub, you'll be right at home with this. A link is right at the top right corner of the rweekly.org page for you to send that pull request with the template already ready for you to complete. And also, you can find us on the social medias, causing some amount of trouble there or not. But I am also, well, what are my big three? I should have it memorized by now. I am on Blue Sky with @ourpodcast at bsky.social. I am also on Mastodon, where I'm @ourpodcast at podcastindex.social. And I'm on LinkedIn. You can search my name and you'll find me there, certain announcements and other fun things I'm working on. Mike, where can the listeners find you?
You can find me on Blue Sky at mike-thomas.bsky.social. And a big shout out to John Harmon, who was super excited after our long absence 2 weeks ago when we came back. So really appreciate the shout out from John on there and the excitement about us getting back on the mic. Last week was not our fault. There were no highlights, but we hope to be a little more consistent going forward. And you can also find me on LinkedIn if you search for Ketchbrook Analytics, KETCHBROOK. You can see what I'm up to.
Yes, Mike and I are just working out our scheduling for the future weeks. We think we got a good spot. We're going to, at least more a problem on yours truly side, protect that calendar, folks. Man, sometimes it just gets to be a Wild West out there. But if you know, you know. Anyway, we're going to close up shop here on this episode of our Weekly Highlights. We, again, thank you so much for joining us, and we hope to have you listen to next week's episode of our Weekly Highlights next week.